Today we're going to be looking at the NEMA 17 stepper motor. We're going to model this up in a number of parts. This is going to contain what we call derived parts, and we're also going to do an in-context part, which is going to be made up of the body of the motor. So just looking at the screen over here, you can see we have got four separate parts. We have the base just down over here. We've got the top cap, so we'll call this the base cap or the bottom cap, and the top cap, and then we've got this little section in between which we'll call the body. We also have this section here, item number 3, which is the shaft. Now I've got the parts just listed up in the top left hand corner there. This is the drawing that we're going to be working from. We will be modeling up all these pieces. You will see we've also got some bearings in here. I've listed the bearings, and I've also listed the bolts that go in to make this whole thing up. So let's get into this. Very first thing is we need to jump into Inventor. Okay, and you're going to need to set up a project. Because this is going to be an assembly, what we're going to need to do is make up a project folder that's just going to guarantee that all our parts go into the one location, and we don't end up with any dramas with Inventor looking for bits and pieces. And once we've done all this, we're going to do a pack and go. It's just going to allow us to take all the components. This is the parts that we model, also all the nuts, bolts, bearings, any other bits and pieces that we put in there from the content center. And it's actually going to stick all that into one folder, which will allow us to zip that up and send it through to someone else, or we can upload it to the cloud and all that sort of stuff, which makes things much easier to work with. Okay, so very first thing, if you haven't set up projects before, you can see I've already got one in here called NEMA 17, so I'll run you through the process on how we do this. So to do that, click on the File tab just up the top there, and you're going to go down to the Manage Flyout, and we're going to click on Projects. In here, what you want to do is go to New. So we click on New. We're going to use New Single User Project, so click Next. And under the project name, you'll put something in there. I'll call this NEMA 17A. Okay, so just pop the name in there, NEMA 17. I'll put A after mine. Okay, and just under here where it's got the project workspace folder, okay, that's got my default sort of stuff in there. You can pop that wherever you like just by clicking on this little button and choose your drives. I'm just going to leave that where it's going at the moment. Yep, so once we've done all that, you can just click the Finish button. And it says that the folder doesn't exist. Yes, let's create it. Click OK. And you'll see that pops up in here. So I'll click on the Done button. And you want to make sure that this is the default one that you've got. So just make sure that this little button there is ticked. It's the active project. Now you won't be able to do that if you've already got parts open. It's going to come up and tell you that there's an error, it can't do it. Okay, so just make sure if it says that, just click OK, close the parts, and then it'll still generate this folder, and just go and click on that. All good. All right, so now we've created our project folder, we want to go and start our first part. Okay, so we'll click on the part button, and here we go. All right, so from here, what we're actually going to do is start a sketch. So we're going to do a 2D sketch, and we'll sketch on our default XY plane. Okay, so I'm just going to jump over to the drawing now, and what we're going to look at in this sense, because we're going to make derived parts, what a derived part is we look at, say, the top cap and the bottom cap, and we're going to find all the components that they have in common. So what we're looking at, you'll see there's a little note here saying the internal dimensions are same for both caps. So that means all this little boss in here, the counter bore that the bearing sits on, this octagonal shape, hole centers, all those types of things, even the outside shape and all that, are the exact same for both the top and bottom cap. However, if you look at the top cap, we've got this little upstand boss here, okay, which has a 22mm diameter, 2mm high. And we've also, in the bottom, we've got this little cutout here. Okay, that's just for where the cable's going. We're just going to make that an indicative sort of thing just to show that it's there, but we're actually not going to cut it all the way through. So yeah, that's really the only difference. This one has that little bit there, and the top cap has this little piece here. So what we're going to do is we're going to create one part that we're going to call that the base part. and then we're going to use that to derive from to make multiple parts. Where this comes in handy is if you've got multiple variations of the same part, you can make a base part and then you can just make as many derivations as you like from that part and just make minor changes, and then you've got a whole heap of different parts, if that makes sense. All good. Anyway, so let's go and have a look at this. So this gives you an idea of what we're doing. We can start with the base part. So we know that it's got an outside dimension of 42.3, and that is square. Okay, and yeah, so that's the very first thing I'm going to do. So jumping back into Inventor, let's go and start with a rectangle. We're going to use 2-point center. Following best practice, we're going to go around the center point, and we want to keep everything as symmetrical as possible. In here, I'm going to put in 42.3 and then just press enter. Notice I didn't press tab to jump over and put the other dimension in there. The reason is because this is square. So rather than having two separate dimensions or making this dimension equal that one, all I'm actually going to do is use these constraints wherever possible. So I'll always want to get in there and try and use these up before I put the dimensions in. It's just going to make simplify our drawing a little bit. From there, I'm going to use the equal constraint. I'll select the equal constraint. I'm going to select this line here. It could be the bottom one, doesn't really matter. And the other one there that's perpendicular to it. And straight away you'll see that's made them, both those lengths, equal. It means I only need the one dimension that I've got here. Okay. Through each step, as we've talked about before, what we want to do is just have a look down the bottom, make sure this is always fully constrained. Okay. All right, that's what we want to look at. We want to try and avoid having anything that is not constrained, because that will cause problems down the track. So looking at this, everything's all cool. It's all that purple color, which means it's all fully constrained. So once we've done that, we're going to finish the sketch, and we're going to extrude that. So using the extrude tool, and I'll just bring this back over. So we're going to extrude, and at the moment it's got a distance of 10. Just looking at our drawing, we need to go 9. Okay, and if you look at that 48 minus 39, you're going to be 9 in there as well. So all good. So we're going to extrude 9. Okay, and it's up to you whether you want to extrude, just from there forwards, or whether you want to go backwards, or in between. I'm just generally just going to stick with this one because I will use that as a plane a bit later on when it comes to constraining my parts into the assembly. So that's all good. Okay. Now, once I've done that, the very first thing I like to do is just get in there and apply a material. So this is going to be made out of 6061 aluminium. Okay, and you can choose whatever sort of texture you would like. I'm just going to go for honed. Okay, so I'll click the pull down. So let's go and choose honed wherever it is. There it is. So I'll click on honed, and that makes it look all pretty. Okay, next thing I'm going to do is popping back over to the drawing. Now normally as best practice we leave all our chamfers and bits and pieces to the end, but for this part that we're doing, it's not going to be too much of a big deal. So you can see here we've got a chamfer. It's 3.33 by 45 degrees typical. And then there's a 2mm radius on all the corners. So if you like, we can go and pop all that in there now. Whether you do this first or later, it's up to you. I'm just going to do it now. So clicking on the chamfer tool, okay, setting the distance here to 3.33. Now, if you like, I don't know why all this is popping onto my other screen, but it's there. So that's what we want. Just choose these edges. Okay. Now notice you can choose the edge from the front, okay, and we'll choose the back edge. You don't need to spin all the way around, but just be careful when you do that you don't accidentally click on the wrong part. So I've done that, click OK, and then what we're going to do is put some fillets in there, radius of 2, and I'm going to go and select all these individually. It's not that many, so it should be fairly painless, and click OK. Alright, so I've got all that done. Yep, all sweet. Cool. Next part I'm going to do is I'm going to put the octagonal cutout in here. So looking back here, we know it's 1.5mm off there. Okay, and it's octagonal because we've got 1, 2, 3, 4, 5, 6, 7, 8 sides. Okay, so meaning an octagon. How deep is it? Well, let's have a look. Can we see that on our drawing somewhere? Yep, we've got here 6. Okay, so it's 6 deep. All right, so that's going to be fairly easy to do. Now, while we'll do this in the same sketch, what we're actually going to do is pop this boss in here, so this little section. So we're going to cut this section out in here. We know that's got a diameter of 25. This is fairly easy to do. All we need to do is create a new sketch, click on the surface that you want to sketch on, okay, and then we're going to create, under the pull down here, we're going to go to polygon, and it doesn't matter which one you use at this stage. I normally go for the circumscribed. We make that 8, click on the center, just drag that out somewhere. It doesn't matter if it's, you know, sort of wonky, because we're going to straighten that up in a sec. Okay, so done. Now what you can do, make sure this is nice and straight. We can either use the parallel constraint, or you can just make it horizontal, since this is horizontal. Probably a parallel constraint at this stage. This way this is always going to stay parallel to that edge. So you just click on this one, click on that edge there. That will rotate it so they're now parallel. Okay, and then we're going to put a dimension between this line and that projected geometry just out here, and that's going to be 1.5. All good. Just looking at it, fully constrained down here, all good. Now, it's not a big deal if you leave this as it is. I'm normally a big fan of just selecting these and making them construction geometry, just so they don't create problems down the track. From there, we're also going to create a circle from this point, and we're going to take that out 25. And that is that for that sketch. So again, just back to best practice, keeping everything as simple as possible. So as you can see, I've only got 2 measurements here. Everything else is all geometric constraints and referencing. So finish that sketch. And then from there, we're going to do an extrude. Now, because we have 2 objects in here, what we need to do is just click on in between here, because we can just click on here and extrude that part. But we want to extrude this piece here, as you can see. Now let's go in the wrong direction, so I'm going to use cut. Now it doesn't matter, if you click cut, it will go that way, and the distance that we're going down is 6. Once you've done, click OK. Alright, so we've got that cut through. Now the other thing we can do is put the hole in here. Okay, to do this, we're going to use the hole tool. Okay, we want to try and avoid just using circles and all that sort of stuff to extrude and cut holes. There's nothing wrong with doing it, but you get a lot more functionality out of using the hole tool. I'm just going to click on hole. Okay, and looking at this, we're going to go from, instead of linear, we're going to use concentric. And under the plane, we want to put it on this plane here, on this face. So we just click there, and you'll see straight away it goes to concentric reference. Your concentric reference is this outside shape here, or this outside surface. So if you click on that, that locates it into the center, and the hole size is going to be 16. Okay, we're getting that 16 just from the drawing here. You can see this here, diameter 16. That is the counter bore symbol. Now it could be spot face as well, but we know it's counter bore because we can see the depth of feature symbol. Okay, and that has a depth of feature of 6.5. Okay, all right. There is a hole that is 10 through, but we'll do that later on when we make the derived part. Okay. All right, so we've got 16. The other thing to make sure that you do is we don't want to go through all. We want to go a distance, and that distance is going to be the 6.5. And the drill point that we want to use is flat. Okay, so it just makes the bottom nice and flat. So we'll click OK on that one. And there is our counter bore all ready for the bearing to sit in. The last thing we need to do for this base part is we're going to put the hole marks in here, but to do this we're going to put them on the opposite face. We're going to do them on this side. Now the reason we're going to do that is you'll have a look, see just in here, okay, just looking at a note on here somewhere, just there, we've got 4, so it's 4 holes, 1, 2, 3, 4, diameter 7, counterbored 2 deep, and they have a 3.5 through hole. So that's going to be on this base part here, okay, because the one we're showing here is the bottom cap. Now on the top cap, there is going to be, these holes are actually going to be over here, as you can see. So this is looking at the top. There's going to be 4 M3 by 0.5 pitch holes. Okay, so What we're actually going to do is just in the part, we're actually just going to put the points in there, so we won't actually cut the holes through because they are different between the top and bottom cap. To do that, because the counter bore is going to be on this side, this is the side we're actually going to put the sketch on. So I'm going to start a new sketch on this face, okay, and yeah, it doesn't matter whether you're upside down. If you're worried about it, you can flip it around so you're looking the right way. And all I'm going to do in here is use the point tool, and I'm going to click on just roughly where I want 1, 2, 3, 4. Okay, notice they're just rough. Okay. Use your horizontal constraints to line these points up horizontally. Okay, there and there. Okay, and we'll use vertical constraints to line these ones up there and there, there and there. What that's going to do is, you'll see now if I click on these and I move them, okay, anything that's associated will move as well. Okay, so it's all good. The other thing we're actually going to do is put a dimension between that one and that one. Okay, and that's going to go up here somewhere, and we know that is, let's have a look at the drawing, it is 31. Okay, so we'll put in 31 there. Okay, that one's done. Okay, and then what we're actually going to do is do a dimension from the center to that one, and we're just going to pop that in there. And what that's going to equal, if we select this dimension here and go divided by 2, that's going to make sure it goes in the middle. Okay, and we can do the same thing this way. So if we click between there and there, okay, and pop that out here, okay, and we can say that one is equal to that one. Done. Okay, and then we do the same thing this way from there to there. That one is equal to that one. Done. Fully constrained, everything's sweet, and we're just going to finish that sketch there. Okay, you can pan around, look wherever you like. Okay, maybe go and have a look at that. But that's pretty much your base part done. So we've got all the geometry on this base part that is sort of the same on both the top and the bottom cap. So let's go and save that. So we'll go save. Now this is going to save it straight into our project folder. I'm going to call this just base and click save. All done. I'm just going to stop this little tutorial here. You can have a go at that. You can go back and rewind, play as many times as you like, and go from there.